Very good morning to everyone. Good morning to everyone. Good morning. A very good morning to everyone. So we have already discussed three reducing reagents, three reducing agents. Okay. Good morning, Purple. Okay, very good. Just tell me one thing, my audio is okay? Am I audible clearly? Am I audible clearly? Good morning, Dhaneshwari. Am I audible clearly? Please tell me once. Hello. Okay, clear. Okay, very good. Very good. Okay, we'll start within 2 seconds. Okay, so let's hear the live and like the live. Okay, so we are talking about reducing agents. Okay, now today we'll talk about SeO2, selenium dioxide. We'll talk about selenium dioxide. Okay, so as per you know what is the topics covered today. The main motive of this session is to unblocking your fear about CSIR NET examination and busting all the myths about your reagent chemistry and solving the important question of SeO2. Okay, so so before starting, from the previous question, from the previous lectures, one question is here. Please answer for this. One question is given here. Please answer for this. Yeah, oxidizing agent. This is an oxidizing agent. Okay, so tell me the answer of the following question. So what will be the answer? See what happened here. This carbonyl group gone, and here this ester group is converted to a olefin. Try it. You will get the answer. Dhaneshwari B. Anyone? What will be the answer? Anyone? B, Anki B. So you are telling B. Anyone who are watching this live, please tell me what will be the answer. It's a easy question. It's a very easy question. Try it, very easy question is. Okay, A. Okay, let's see what happened. So this group is gone, so we can go for BH3THF. Okay, why why BH3THF? Or otherwise we can say, let's see every one by one. Okay, let's see the reactions one by one. Okay, so using BH3THF, what happened? That using BH3THF, both will be reduced, that the amide group will reduce to amine, and this group will reduce to aldehyde or alcohol. The ester will reduce to alcohol, so this option is incorrect. Okay, the A option is incorrect. The ester will reduce to alcohol, as well as option D also incorrect. Now similarly, option C, if you use lithium aluminium hydride, see in case of lithium aluminium hydride, there will be the product of the first reaction. In case of C, this will be the product, and like what happened, there will be OH and there will be NCH3. This will be the product. Okay, after that we are using PCC. Now what will happen when we are using PCC? PCC will oxidize this. So if PCC will oxidize this, then we will get this. Okay, then we will get this, and after that this one, and NCH3 is there. And in the last step, what happened? In the last step, it will be go for CH2 PPH3. This is Wittig reaction. Okay, so for this we will get this product will formed. So correct answer is C. Now let's check B. Let's say B once. See, in presence of lithium borohydride, what happened? See, the lithium borohydride cannot reduce both. It cannot reduce ester, it cannot reduce amide also. Okay, so option B is incorrect. Okay, so therefore, there is a very important notice for you guys, that is, if you have already prepared, or if you have already have the exam, have done the exam in CSIR NET December. Okay, in CSIR NET December 2003, as you know, the scorecard has been published. Okay, so you can go to our IFAS rank predictor. You can easily know your rank, whether you are qualifying in lecturership, LS, or assistant professors, and whether you are qualified for JRF. So don't miss out, go and check this out. Okay, so go to IFAS, www.ifasonline.com, and you will get this IFAS rank predictor, and tell me what is your rank in this comment. Okay, sir, my number is 84.500 OBC. So check there, you go and check there. Okay, and tell me what is your rank. Okay, let's start. So today we are talking about Seo2. Seo2 means selenium dioxide. Okay, so selenium dioxide is so it is excellent reagent. It is an excellent reagent for oxidation at alpha active carbonyl, alpha active carbonyl compound. My rank predictor is 152 is qualify? No. If it is 152 in JRF, you will qualify, but if it is in lecturership, it will not qualify. Lecturership is only for 50 to 45 ranks. Okay. So so let's start that that it is an excellent reagent for oxidation at allylic position. Allylic, not allylic, like alpha active carbonyl compounds. Now what is alpha active carbonyl? This is carbonyl group. So if a carbonyl group has alpha hydrogen or hydrogen in alpha position, okay, hydrogen in alpha position, so that will called as that compound will called as Seo2. Okay, that compound is called as Seo2. Okay, now what reagent we are using, that is Seo2 plus H2. Seo2 is water soluble and it will give H2SeO3, selenious acid. Okay, it will give selenious acid. Okay, so this is a very important reagent for oxidation in allylic position. In many cases you will see that Seo2 are given to you and further reactions are happened. Okay, so let's start. So selenious acid. Now what is the application? There are four application. Let me see, there are 3 application. Okay, so total 3 application I have drawn here. See, one application when you use in carbonyl compound in presence of Seo2, water and heat, it will give 1,2-dicarbonyl compound. 1,2-dicarbonyl compound, that means one carbonyl compound will attach to this carbon. Okay, similarly when we use a double bond having allylic position. Sir, how many students maximum qualify? Good morning, Swadpist. How many students maximum qualify? See, it depends the seat structure, but in case of lecturership, it will maximum for chemistry. It will maximum for I think 60 to 70 people for LS only. Okay, and for JRF it will be gone for like 150 and something. Okay, so 150 for CSIR NET and 150 like total seats in JRF, I think it will become for 350 700. It's around 700 people will qualified for JRF around. In last 2023 December, 2022 June, like 2022 in September exam, where I did the exam. So there will be around double seat. The seats were doubled and the seats were around 1152 and plus 700. So 1,800 seats are there. Okay, so see, come to this. Okay, so if we are using carbonyl compound using selenium dioxide and water in presence of heat, it will give the 1,2-dicarbonyl compound. So if you are using this kind of compound, this allylic compound, so in presence of selenium dioxide, H2O and heat, it will give alcohol in this allylic position. It will give alcohol in this allylic position or CHO in this allylic position. Okay, or CHO in this allylic position. Okay, so we'll get this kind of product. And we will go for the stereo selectivity for that. Okay, so we'll come into that. And the third application is if we use benzylic position in presence of Seo2, H2O and heat, it will give in benzylic position, it will form this. Okay, now what happened? What is the mechanism? Mechanism is very simple. Mechanism is 2,3 sigma tropic reaction. Here we will go for 2,3 sigma tropic reaction. In pericyclic, you already know that the reaction is 2,3 sigma tropic reaction. Now what happened here? So we are using this carbonyl compound CH3 acetaldehyde. So in presence of acetaldehyde, we know that it can converted to ketoenol tautomerism. It can converted to ketoenol tautomerism in presence of water. Okay, so where you will get this. So I am drawing this like that, hydrogen and hydrogen. Okay, now in presence of selenious acid, we are using Seo2 plus H2O. So selenious acid, what is selenious acid? Say selenium OH, and here will be OH, and here will be double bond O. This is selenious acid. Now in presence of this, what happened? This oxygen will take up this hydrogen, and this bond will come to this. Okay, this bond will come to this, and this double bond will attack to this position, and here will be negative charge. This is not 2,3 sigma tropic reaction. We'll come into it. Okay, so after that, what happened? The product formed. Which product formed? That there is an intermediate like hydrogen, and there will be double bond O, and there will be hydrogen, and there will be hydrogen. Okay, and there it is attached to oxygen, and oxygen is attached to selenium, and selenium is attached to OH. Okay, selenium is attached to OH, and here will be OH, and here will be negative charge. There will be negative charge. Sorry, OH2 positive. So there will be negative charge. Okay, so after that, this OH2 positive will leave. And we'll get the product. We'll get the intermediate or product. We can say that this kind of thing. This one, hydrogen. This one, oxygen, selenium, OH. Okay. So so this kind of product. So after this, what happened? That this hydrogen will remove, and this selenium will remove. Okay, so after this we will get this product, the final product. So this is the mechanism. Okay, this is the final mechanism of using selenium dioxide in acetone or in carbonyl compounds. Okay, understood? Okay, so so in presence of, we can say, so in presence of this Seo2 and heat H2O, will get this product. But you will tell, sir, what will happen? It is a symmetrical carbonyl compound. But what will happen? We are using unsymmetrical carbonyl compound. So see, in the mechanism, the answer is hidden. In the mechanism. What happened? That the first step is to form enol. Okay, the first step is to form enol. Now, if we are forming enol from this side, it will be unstable. If we are forming from this side, it will be stable. If we are forming from this side, it will be stable. So the enol will be formed for this side. So therefore we can say the product, the CHO group will be the carbonyl group will be attached to this carbon. So the product will be this. Easy? Is that easy or not? Tell me, everyone, is that easy or not? Tell me in the chat, is that easy or not? I think so, very easy. Is that easy or not? Easy? Okay. So go up. Next, second application. So there is a catch. What is second application? I already told you that in presence of this kind of compound, Seo2 and water, if in presence of heat, okay, so we'll get this alcohol. Okay, in some cases you will get this same. This and this will be same. They are oxidized product. Okay, so both are oxidized product. In many questions this will given, in many questions this will given, in many questions this will given. So see, one more thing, this is not the important for this application. The main important thing for this application, tell me one thing, a double bond or an olefin, carbon and carbon, how many allylic positions a double bond can achieve? A double bond can have how many allylic position? Is that 1, 2, 3, 4, 5, 6 in numbers? So how many allylic positions are there for one double bond? What? So what we say, at least 2 hydrogen adjacent to the carbon atom. No, see, there must be alpha position. There must be alpha position. This is alpha active carbonyl. If we are using not alpha active carbonyl, there will be no reaction. So there must be alpha active carbonyl, and the alpha active CH3 will be carbon will attach carbon double bond O. Okay, that's it. So a double bond has only two allylic position. No, see, this is double bond. These two positions are called as vinylic position, and this position is called as allylic position. Okay, so a double bond can achieve for 4 allylic position. See, this is 4 allylic positions are there. 4 alpha position or 4 allylic positions are there. So this is interesting, very interesting, that how do you know that where the alcohol group will attached? How do you know that where the alcohol group will attach to the allylic position? Okay, we never know. So there is a rule. Okay, there is a very cool rule. See, the rule is called Gilmore's rule. Okay, so see, I was asked you that a double bond can achieve. Okay, so the rule told everyone that the first rule told that Seo2 selectively oxidized sp2 carbon having more substituents. Now for example, a double bond has one carbon compound or one methyl group in this side, one allylic position, and this carbon has 2 allylic position. One allylic position, this carbon has 2 allylic position. However, this is bigger group, but the alcohol, or we can say the oxidation, will occur in the allylic position of this carbon compound, of the allylic position of this carbon. Okay, because it is more substituted. So the first thing we have to check the more substituted sp2 carbon. The first thing we have to check the more substituted sp2 carbon. Okay, so next thing, so the oxidation will occur from 2 degree carbon, 2 degree allylic position, then 1 degree, then 3 degree, then 1 degree, then 3 degree. So for example, you can tell me that there is a compound, and here this one and this one. So there is 3 allylic position A, B and C. So in presence of SiO2, H2O and heat, what will happen? The alcohol group will attach to which position in ABC? A, B and C, the alcohol group will attach to which position? Tell me. A, of course A, because it is a 2 degree and this carbon is more substituted, so the product will be this. Now there is a catch again. So if the carbon or allylic positions have same hybridization, if the carbon or allylic position have same hybridization, so here the third rule came, that always prefer E configuration. Always prefer in E configuration. For example, there is a compound this and this. So where it will be attached A, B and C. Where it will be attached A, B and C in presence of ACO2, H2O, where the oxidation will occur? Where the oxidation will occur? Tell me, in presence of ACO2 and water, A, B, C. Yes, very good. It will be in B. Okay, so it will be in B. So this product will happen. So this is E. This product is happened. This is E. Now there is, or almost we have know that where will be oxidation occurs, but there is also a catch. There is also a catch. So if there is more than one double bond, if there is more than one double bond, so we must know the electronically rich double bond will oxidize. So tell me one thing. Okay, so tell me one thing. So in this double bond, okay, tell me there are 4 allylic position A, B, C, D. Okay, E, 5 allylic position. So which will oxidize? In presence of ACO2, H2O in this compound A, B, C, D, E, which will oxidize? Tell me. C. Which will oxidize? C. Yes, very good. See, this double bond is electronically poor because CHO electron is an electron withdrawing group. Okay, so here this double bond will be oxidized. This allylic position of this double bond will be oxidized. So therefore, for this double bond, this carbon is more substituted, and this carbon, this is 2 degree. Okay, no, this is not 2 degree. This is 3 degree, and this is 1 degree. So we know 2 degree greater than 1 degree greater than 3 degree. So therefore the OH group will be attached to this position. Okay, understood everyone? Dhaneshwari, understood? You understood? Okay, very easy. This is interesting and easy. Okay, it is interesting and easy. Okay, so next rule is very important, that the fifth rule states that in monocyclic molecule so C is 2 degree na? No, this is 3 degree. This is not 2 degree. C is 2 degree. Yeah, C is 2 degree. Sorry, this is not 1 degree. This is 2 degree. Yeah. My bad. This is 2 degree. So 2 degree greater than 1 degree greater than 3 degree. Okay. So this is 2 degree. Okay. Thank you. So the fifth rule states that in monocyclic molecule, part of cyclic allylic carbon, the part of cyclic allylic carbon will be oxidized. So for example, if we are having this kind of compound like this, okay, so in general what will happen? We know that E product will form. So to forming E product, it must attach to this position, but it will not. It will attach to, in presence of ACO2 H2O heat, it will attach to this position for monocyclic compound only. You need to remember, for monocyclic compound only we will get this product. Now why we will get this product? The same thing we know, that the mechanism. The same thing we know, that the mechanism, the enol production, or we can say that the mechanism it happens, the hydrogen will takes up and something all. So the mechanism will responsible for this rule. Okay, the fifth rule. Okay, understood? So the last rule, sixth rule states that, infused bicyclic system, the small ring, we have to check at first the small ring, okay, or we can say the strained ring, will be oxidized. For example, this is a fused compound, so this is also 2 degree, this is 2 degree, this is 2 degree, this is 2 degree. So you are completely confused where the alcohol will attach. Okay, so we will attach to this position. Now you will tell that why not this position? So both are same. Okay, so both are same position. Understood? So these are the rules. You understood, everyone? These are the rules of Gilmore's rule to addition of alcohol or addition of oxygen in the allylic position. Okay, so is that easy or not? Many of you already thought about that selenium dioxide or oxidizing reagents are very tough. Okay, so are very hard, but it is very easy. Just we need to go we need a very good pathway. Okay, again the last application we have. Why not upside? See, just draw the upside one, the product will be same. This one the upside one, okay, and this one the lower side one. So product will be same. Okay, the product will be same. Okay, so this is very general. Okay, so next, third application was this benzylic position. So we'll get this product. CHO. Okay, so or otherwise we can say that the product will be this kind of thing, this one. Okay, and there also the same thing happens, that 2 degree greater than 1 degree greater than 3 degree. That means if there is this, so the product will be in presence of Seo2 H2O water. So A, B, C. Tell me which allylic position will oxidized? Tell me which allylic position will oxidized? C, of course. So C will oxidized. Okay, so B will not oxidize because it is 3 degrees, so there will be no double bond O. So B will not oxidized. Okay, so in A and C, C will oxidized. Okay, so this is for SeO2. Okay, everyone understood? This is for SeO2. So now going for the questions. Okay, so before starting our questions, I am telling you that there are many more things which will watch this video later. There are many more things in our website, that the paper analysis of 12 years, 5 years cutoff, 12 years PYQ and exam related, all the information about CSIR NET examination. If you are looking for CSIR NET June examination, okay, so if you are really worried about your preparation, you go and purchase all the things. It is completely free. You have to log in. You have to just log in into our website. Okay, you have to just log in into our website. Okay, so let's start our first question. Today's first question. Just tell me one thing, the question is visible or not. Just tell me one thing, the question is visible or not. Tell me one thing, the question is visible or not. Sir, how 3 degree oxidize? 3 degree will not oxidize. 3 degree will not oxidize this case. In allylic position it will oxidize, but for benzylic position it will not oxidize. Okay. Okay, tell me what will happen. Very easy. You know what will happen. See here the options, option A, they use in alcohol instead of aldehyde. Okay, so remember one thing, so there may be alcohol, there may be aldehyde. Okay, there may be alcohol, there may be aldehyde. So in the first step we know that option A and option B is incorrect. See, a simple thing can eliminate two options of your question. So that's the magic, that's the crux of your organic chemistry questions in CSIR NET or GATE examination. So a simple thing can eliminate two options. So the option A must be this. Okay, the option A must be this. The next reaction, it is a very famous name reaction. Can anyone tell me what is this reaction? It is a very famous name reaction. Can anyone tell me what is this reaction? What is this reaction? Can anyone tell me? Very famous name reaction. This is Mannich reaction. Okay, this is Mannich reaction. So from here we will get Mannich base and it will attack to that carbonyl compound. Yes, Mannich reaction. It will attack to this carbonyl compound and we will get option this. So correct option is option D. Correct option is option D. Okay, so let's go for the next question. It is also a very easy question. Tell me what happened. Tell me what happened. It is a very easy question. It is a very easy question. Tell me everyone, what happened? A 45A, Dhaneshwari C. Okay, Dhaneshwari, please look the question clearly. See the question. See the question. Everyone, see the question. What will happen? What will happen? 2,3 sigmatropic rearrange. Yes, very good. 2,3 sigmatropic reaction. And not 2,3, it will be 3,3. The second step will be 3,3. Okay. So here the reaction is, I am writing the mechanism. At first the in reaction happened. In reaction. Then for SeO2, it will go for 2,3 sigmatropic. And after that we will go for PCC, it will be 3,3 sigmatropic. And the reaction is called as Babler oxidation. The reaction is called as Babler oxidation. Okay, understood everyone? The reaction is called as Babler oxidation. Everyone understood? Tell me, what will be the answer? A or C? What will be the answer? A or C? What will be the answer? See, there is very simple thing. We know that there is only and only one allylic position, so the alcohol will attach to this position. This is a simple thing. Okay, this is a very simple thing. So from this we can eliminate B, D and C. From this is the compound A. From this we can eliminate B, D and C. Okay, from this you can eliminate B, D and C. Draw the mechanism, please. Mechanism we will draw. This mechanism is very vast. Okay, so we'll draw it in any day. So you can go Babler oxidation mechanism. You can go through that. Okay. So after this, what happened? We are using PCC. We are using pyridinium chlorochromate. So this is also an oxidizing agent. This is also an oxidizing agent. Okay. Remember PCC. What will do PCC? PCC in presence of PCC, alcohol will oxidize to carbonyl compound. Simple as that. Simple as that. Ki alcohol will oxidize to carbonyl compound. But it must be 1 degree or 2 degree. It must be 1 degree and 2 degree. Now what about this is 3 degree alcohol, tertiary alcohol. This is tertiary alcohol. So it will oxidize or not? It will oxidize or not? So see what happened. Here rearrangement occurs. That is 3,3 sigmatropic reaction. Here we will get 3,3 sigmatropic reactions. That oxygen will attach to this position and double bond will shift and we will get the product this. And this is called Babler oxidation. This is a very good tool. This is a very good tool for oxidation of 3 degree alcohol. So correct option will be option A. Correct option will be option A. Sir, is there course available in English from your platform? Yes, of course. I think so. There is course available in English. See Anusha, right? Anusha. So see the PPTs or the study materials, all you have in English. Okay, in English. So there is I think there is no batch for English. If you are interested, you can join ourselves for English lecture. So there is a opening for English batch. Okay, so you can join us. Next question, very simple question. Tell me what will be the question for this. What is the question for this? Next question, very simple. So if you are not like the live, please like the live. Okay, by liking the live, I have the motivation to do this such of things for you guys. Okay, since 4 days I am talking about the reagent chemistry, the important reagents I am talking about, and as well as today also, you know that the complete rules I have told you. Okay, so for me, for this channel, for this video, keep liking and sharing this to your friends. Okay, so as much as you guys will join this live. Okay, so what will happen? See, so this is very simple. That one carbon is left in this position. So the correct option will be option C. This is very simple question. The correct option will be option C. So after that, there will be no wrong answer from your side. I don't need any wrong answer from your side when it comes to Seo2. Okay, selenium dioxide. Tell me one thing. Just tell me one thing. This after this lecture, you know all about selenium dioxide. Rather than any other reagent, any other actions, you know all about questions. Sir, will you complete all the reagents? I will try for that. Okay, I will try for that. In this week, we will only complete DDQ. After that, tomorrow will be complete for DDQ, dicyannoquinoline, and after that organometallic reagents, and there will be a minimal organometallic reagents that like Grignard, lithium and organocopper. After that, if possible, I will do for you guys. Okay, if possible, I will do for you guys. Okay, so tell me what we so tell me one thing, that after this lecture, there is no fear about selenium dioxide or not? Tell me one thing. So Tell me one thing, sir, that all fear is gone about selenium dioxide, yes or no? All fear is gone about selenium dioxide, yes or no? That's my goal. That's my goal. Okay. Your goal is to learn. Your goal is to learn everything about selenium dioxide. Okay. Is every week change? And teachers, I don't know. I don't know what happened to the next week. Okay. So you will get all the things. And if you want to learn this kind of thing, you can join us. There is such recorded course. Okay. There is such recorded course. And the batch has been started from 29th January. The batch is already been started from 29th January 2024. Okay, 2024. So this is the price list. This is the price list. This is the original price, and the discounted price is this. So you have to use 75% off using, say, IFAS 75. Using IFAS 75, you will get this courses in this price. Okay, so the prices are there, the materials you are given are there, so you just need to join us. Similarly, today's lecture, you will don't have any fear about organic chemistry. That's my guarantee. You will not have any fear about organic chemistry after joining this batch. Okay, that's my guarantee from my side. Okay, after that, your thing that how much you are going to practice all the thing. Okay. Okay, so next question. Tell me what will be the question. Next question, this. Tell me what will be the question. It's a very easy question. Tell me what will be the question. In first step, it will be copper iodide. In second step, it will be selenium dioxide. And remember, this question will came in the next CSIR NET examination. This is a very important question. Structure of the major product. This is a very important question. You know about that. How much topics will teach by Hitesh in that course? It's like the reagent. I will teach reagent, and I will teach you geosyn stereochemistry. Sir will teach reaction mechanism and reactive intermediates also. I taught you, or Hitesh sir. So there you can say that we have already 3 and 4 faculties for only for organic chemistry. Okay, so don't worry, Hitesh sir always there. Hitesh sir is always there for you. Okay, I am always there for you. Nugesh sir always there for you. So don't worry. Okay, so this is the most important question. Okay, so try it. Very easy and most important question. Carbon rearrange and next Seo2 alkane. So tell me what will be the product. Man. This is not the answer. What will be the answer? 1, 2, 3, 4. I have already drawn this product. What will be the answer? What is the answer? Tell me that. A will be the answer. Anyone else? What will be the answer? Spot piece 1. Anyone else? What will be the answer? Tell me. What will be the answer? A. Vishal Khetre, A. So there is simple thing that whenever you have carbon attached to nitrogen, N2, so in presence of heat, light, or transition metal like copper iodide, this N2 will break and will get carbene. So what will get that here the carbene will form. So what will happen? Here the carbene will formed. Okay, so this carbene, now one more thing, that when the carbene is formed, carbene is looking for electron density. Carbene is looking for electron density. It will go to electron dense position. So it will attach to this. It will attach to this double bond. So number of carbon or number of ring 1, 2, 3, 4, 5, 6. 6-membered ring and attached to a 3-membered ring. 6-membered ring and attached to a 3-membered ring. So 6-membered ring attached to a 3-membered ring. So correct, the first compound will be look like this. This one, and there will be this and this thing and 6-membered ring, okay, and attached to a 3-membered ring. 6-membered ring is attached to a 3-membered ring. Let's number 8. Let's number 8. So this is 6 and this is 1. So 2, 3, 4, 5. Okay, so in 3 it is attached to CO2Me. Sorry, in 3, right? In 3 it is attached to CO2A. And 2 and 3 there will be a double bond. 2 and 3 there will be a double bond. So this is the product 1. This is the product 1. Now one more thing that this compound is Z. This compound is trans compound, E compound. So if it is in E compound, the product also be E. The product also be E. So the methyl group, if the methyl group is in above, the hydrogen will be in below. The hydrogen will be in below, as well as the hydrogen will be in below. And there will be hydrogen in below. Okay. So this will happen. And remember one thing, when 3-membered ring is attached to 6-membered ring, 3-membered ring, it attached to how 3-membered ring formed. See, carbene insertion. So this double bond, and in presence of carbene, this is CH2 carbene. So it will attack and it will attack. So the carbene formation in this. Look, the Simmer-Smith reaction also. This is also important for you guys. Okay. So what happened? This carbene will attach to this and 3-membered ring formed. Okay. Now after this SEO2 came here. So one double bond only here. Only and only one double bond. Why not this double bond? This double bond is electronically poor because CO2Me is attached to it. See what's the interesting thing about selenium dioxide and what is the important thing about this reaction. It makes perfectly for selenium dioxide that this double bond will oxidize and it will be formed E product, E alkene product. So here will be attached to alcohol. So correct option will be option 1. Is that a very interesting question or not? Tell me. Is it very interesting question or not? Tell me one thing. It's interesting? Yeah, Dhaneshwari, it's interesting or not? Okay. Okay. Going forward, the last question of today. SEO2 allylic alcohol. Very good. Last question of today. Tell me what happened. What will be the product? Tell me. What is this reagent? You know about this reagent. You already know about this reagent. I think so. It is salt only from SEO2. Yes. It will solve only from SEO2. No, I think. It will solve only from SEO2. It can be solved only by SEO2 also. 121 out of 200. Sir, what rank I will get in net? You will get very good rank under 50. You will get under 50. Okay. In JRF you will get under 50 rank. So there is a rank predictor. You can go to our website and you can predict your rank. Shivani, you can predict your rank easily. You go to our website. Okay. You can predict your rank from IFAS rank predictor. Okay. From IFAS rank predictor you can predict your rank easily. So go to ifasonline.com. So this is the last question. So we know this is Wilkinson catalyst. So Wilkinson catalyst will reduce only electronically poor. Will reduce electronically poor species. Electronically poor double bond. Okay. It will reduce electronically poor double bond. So therefore this is electronically rich, this is electronically poor. So which option will be eliminated? That option A will eliminate and option D will eliminate. Okay. So So option A and D will eliminate. So product will be P. Now for Q, we are using SEO2. We are using SEO2. So what will happen? What will happen? That this carbon is more substituted and product will be attached to this position, but the product in the option C attached to this. The carbonyl group attached to this. So option C incorrect. So option B is correct. This will be the product. Option B is correct. This will be the product. Okay. This will be the product. We know that E alkene will form. We know that E alkene will form. Okay. So therefore the correct answer is option B. Hopefully, I am wishing that you all guys have no fear about what? You all guys have no fear about SeO2, selenium dioxide. What are you talking about? Wilkinson cis hydrogen given from less inert side more than electron rich reduce. Yes, Wilkinson, the simple thing that Wilkinson will reduce electronically poor. That's the simple rule. Electronically poor double bond will be reduced. Okay. So this is tri-substituted and this is mono-substituted. So this is electronically rich and this is electronically poor. So this will reduce first. Okay. This will reduce first. All clear about SeO2. Thank you. So if you want to clear all the reagent, you can join us. Okay. So there are 1000 plus IFAS qualified in CSIR or UGC NET examination. Okay. In June 2023 already. Okay. So you can join us. So for today, thank you for joining everyone. Okay, so thank you for joining. You can go and download our IFAS app to get many more things like this and many more notification when the class is going on or not, when the YouTube class is going on or not. Okay, so thank you all. Thank you.